Alright guys, welcome back to Underground Science, and in this video we'll be looking at an example of balancing redox reactions in base, okay? So if you haven't already, go and check out my balancing redox reactions in acid, because once you know that, once we get the steps down for that, this is pretty much the same thing, except the only difference is we do a couple of extra steps at the end. Alright guys, so let's go and jump into our example right away, okay? So let's look at iron 2 plus. All right, so iron 2 plus right here. We're going to add that with our bromate anion. All right, so we're going to add that with our bromate anion. And from that, we're going to result, or it's going to yield iron being oxidized. All right, so iron's going to get oxidized. And we're going to have bromate turn into just a Br and a minus. All right, so it's going to be the bromide anion. All right, so let's go and write that down. Bromide anion. Okay, so remember from the balancing redox reactions in acid video, our first step was to take this reaction that we see here and turn it into two half reactions. Okay, because the reason why we call it as half reactions is because we have to see whether it's going to be a reduction half reaction, not a full reaction, or an oxidation half reaction. Okay, so let's go and separate this whole thing into two smaller half reactions. So one half reaction is our Fe2 plus, our iron 2 plus, is getting oxidized into iron 3 plus. All right, so here we can tell that this is a oxidation half reaction, because an oxidation, when we talk about something getting oxidized, we're talking about something losing electrons. So if we go from a 2 plus charge and we go to even a more positive charge, means that we're letting go of something negative, which is why we could become more positive. So we're letting go of an electron here, so that way we're gaining a positive charge. Right, so iron is getting oxidized, and we'll see soon how to tell even better that if we have an oxidation half reaction or a reduction half reaction, right? But first, let's separate our reactions out. So then our next half reaction is going to be our bromate anion turning into our bromide anion. All right, so now once we write our two half reactions, so let's go and write this out. These are our two half reactions. All right, so that was the first thing. We split it up. Now let's go ahead and balance everything, except remember our two exceptions we talked about in our balancing and redox reaction in acid videos, that you have to balance all the atoms out. Remember, because of law of conservation of matter, we still have the same number of atoms on the product side. So we have to balance the atoms out, but we don't balance it out regularly like we would for oxygen and hydrogen. Okay, so for oxygen, we would balance out by adding water molecules to the opposite side, and then we'd go back and add hydrogen molecules or hydrogen cations to the other side. So let's see what I mean by that. So if we look at this oxidation reaction right here, right, this oxidation half reaction, iron 2 plus oxidizing to iron 3 plus, first we look at the number, first we balance. Well, it's already balanced. We have one atom of iron 2 plus here, we have one atom of iron here if we just look at the overview, and one atom of iron here, so we don't have to balance anything. Again, we don't have any oxygens to worry about. Here, we have bromate anion turning into a bromide anion. So bromate, we have one atom of bromine here, and we have one atom of bromine here. So we don't have to balance bromine, but look what happens here. We have three oxygens here. But how are we supposed to balance it on this side? Because we have to have the same number of oxygens on both sides. So what you do is that you add three water molecules to the product side, okay? So let's go and rewrite this. So we're going to have our bromate anion, and then we said we have our bromide anion here, but we have to balance, sorry about that, we have to balance, again, the three oxygens, so we're going to add three water molecules to balance our three oxygens out on this side. See, now we have three oxygens because of our coefficient of 3, and we have three atoms of oxygen here also, three atoms of oxygens. Okay, but now we have another problem. now we have 6 hydrogen ions here, or 6 hydrogen atoms here, and 0 here. So that's the next step, right? So now we have to add 6 hydrogen atoms on this side of the equation, on the reactant side. Okay, so now let's go and write that. So let's go and add that out, or add that in, I should say. 6 hydrogen cations, pretty much protons, plus, and then we keep everything the same. So it's going to be our bromate anion, and it's going to turn into our bromide anion. Sorry about that. Our bromide anion and our 3 water molecules. Okay, now if we look at this reaction, we should be happy now. Okay, because why? Because we have one bromine atom here, one bromine atom here. So bromine's good, right? 3 oxygen atoms here, 3 oxygen atoms here, we're good. 6 hydrogen atoms here, 6 hydrogen atoms here, we're good. All right, so now let's go and write both the reactions down here so we can see both of them. Okay, so let's go and write our iron 2 plus to iron 3 plus oxidation half reaction, all right? So iron 2 plus to iron 3 plus. Okay, so far we have these two reactions finalized in terms of balancing our reactions. Okay, next step, we balance the charge. What do I mean by that? You look at the charge on both sides of the equation and you add electrons to compensate the charge. So on the left side, let's look at this reaction for now, or first. On the left side, if you count how many charged, the quantity of charge that we have 6 positive charges here, and we have 1 total negative charge here. So what we're going to do is we're going to write 6 positive charges here, and we have 1 negative charge here, or on our bromate anion. So that yields a net total charge on the reactant side to be positive 5. All right, so let's see what we have on the product side. Well, on the product side, I only see 1 net negative charge. So we have a total of -1 charge here. So how do we compensate? We compensate by adding electrons to match the charge. Well, looking at this, we can't add electrons here to match the charge here, because if we add electrons here, this is only going to get more negative. So our only choice is to add electrons here. Okay, how many electrons? Well, we add 6 electrons here, because remember, each electron has a -1 charge. So if we add 6 electrons here, on the reactant side, we're going to end up with a -1 charge, and then we're going to be happy, all right? So we're going to have both sides balanced in terms of charge. So let's go and write that out. So we're going to have 6 protons here, then we said we're going to add 6 electrons, and then everything's going to be the same. So we're going to have a bromate anion, and then we're going to yield our bromide anion and our 3 water molecules. Okay, so it's supposed to be a 3 right here. 3 water molecules. All right, now this is much better because now our charges are balanced on both sides. See here, our 6 electrons cancel out the 6 protons, or the 6 positive charges, leaving us with a net negative charge. And here we also have a net negative charge, so we're good. And so this equation is good in terms of balancing atoms and balancing the charge. Now let's balance the charge on this equation of iron getting oxidized. Okay, so same thing. We have a net 3 plus charge on the product side and a net 2 plus charge on the reactant side. So where do we add our electrons? Which side? Well, it wouldn't make sense to add our electrons on the reactant side, because if we add electrons on the reactant side, we're going to go smaller and smaller in terms of charge, so we're going to decrease in charge. But we have to decrease the charge on the product side because the product side has a bigger charge. Okay, so what we're going to do on the product side is that we're going to add an electron on the product side, which means that now instead of having a 3 plus positive charge on the product side, we're going to have a 2 plus charge, which is going to match our 2 plus charge on the reactant side. All right, so our charge is going to decrease by 1 because we added 1 electron, which is a negative charge. Okay, so now we have we've made some progress and we've gotten down to our 2 reactions, or our 2 half reactions that are completely balanced in terms of atoms, all right, and completely balanced in terms of our charges. Okay, so now the next step after this is to match the number, because our end goal is to add these two reactions together. Okay, but we can't do that unless our electrons, our number of electrons, are equal. So here we have 6 electrons on the reactant side, but here we have only 1 electron on the product side. And again, we have to make these equal, these number of electrons equal in order for us to add them together. So how do we do that? We multiply this whole top oxidation half reaction by 6. Okay, so remember, this is our oxidation half reaction, the top one. All right, we multiply that by 6. So what I'm going to do, let's go and write in orange, I guess. So we're going to take this whole thing and multiply it by 6. And then we're obviously going to leave this alone because our whole goal is to match the number of electrons that we have. Okay, so let's go and do that. So multiply the top one by 6. We're going to get 6 iron 2 plus atoms. All right, 6 iron 2 plus atoms. Sorry about that random dot. And then we're going to yield, so we'll draw our arrow, 6 iron 3 plus atoms. All right, because remember, we're still multiplying the whole thing, right? We're multiplying this whole thing by 6. So we're going to have 6 iron 3 plus atoms, and then we're going to have 6 electrons, which was our whole goal of multiplying. All right, so now if we go and write out our reduction half reaction that we had here previously, we're going to see that everything matches, or our electrons match. Okay, so let's go and write our reduction half reaction previously that we had before balancing all this out. So we're going to have 6 hydrogen cations plus our 6 electrons, and we're going to have our bromate anion, again at random dot, sorry about that, and we're going to yield our bromide anion plus our 3 water molecules. All right, finally, now we have balanced number of atoms on both sides, balanced number of charge on both sides, and we balanced the number of electrons. Or no, we didn't balance. We balanced the we added the necessary amount of electrons in our both reactions, in this case just the top one, in order to match the number of electrons on the product side of our oxidation reaction, our oxidation half reaction, to our reduction half reaction. All right, so now we have the same amount of electrons in both reactions, the product side and the reactant side. Now we can go ahead and add them together. All right, so now let's add those two reactions together, and let's see what we get. So we're going to add those two reactions together. So our 6 iron 2 plus atoms. Okay, sorry about that. I'm going to erase that. 6 iron 2 plus atoms plus, okay, I don't know why these random dots are there, but plus, okay, that was weird, plus 6 hydrogen cations, and then plus our 6 electrons. So again, guys, I'm just adding the reactants of both equations. So I haven't added the bromate yet, so let's go and add that in, plus our bromate anion. All right, now let's go and add both of the reactions of our product side, or the product side of both of our reactions. Okay, so now we're going to add, okay, so let me go and choose the same color. Let's stay consistent. Okay, so now we're going to add, all right, I don't know what's up with those dots today, but I'm going to add 6 iron 3 plus atoms, and then we're going to add our 6 electrons, and then we're going to add our bromide anion. All right, bromide anion, and then we're going to add, lastly, our 3 water molecules. Okay, so now we can see that we have something in common here, okay? We have 6 electrons on this side and 6 electrons on this side. So that means we can just go and get rid of that, because if we subtracted 6 electrons, brought it to this side, we would anyways get 0. So let's just go and cross that off so we don't have to worry about that. All right, so let's go ahead and rewrite that. So we're going to have, try to stay, oh, sorry, I didn't stay consistent with this color right here. It's just be darker orange. All right, now it's going to rewrite that. So we're going to have 6 iron 2 plus atoms here, plus our, can't forget about our protons, or our hydrogen cations, right? Our 6 hydrogen cations there. Then we're going to have our bromate anion here. What's that going to yield? Well, we're going to yield our 6 iron 3 plus, right? So our 6 iron 3 plus, really bad at doing this, staying consistent on the color, sorry about that. Our 6 iron 3 plus atoms, all right? Another random dot, Jesus, another, okay, so, and then we're going to add our bromide anion and our water. All right, let's not forget about the law of conservation of matter. Sorry about that. Gotta make sure we have our balanced number of coefficients here. Okay, now that that's done, if this was balancing an acid, if we had an example of balancing an acid, we would be done. Like this would be our equation of balancing an acid, okay, if we're balancing our redox reaction acid. But remember, this video is about balancing a redox reaction in a basic solution. And that should ring a bell in your mind saying that, okay, we need to have something involving a hydroxyl group. There are many hydroxyl groups. A hydroxyl group is pretty much an OH negative group, all right? And those are basic. Okay, so remember when we're talking about pH, when we talk about acids and bases later, we'll look more into hydrogen cations and hydroxyl groups, okay? So OH minus anions. Okay, so now these are the extra steps that I was talking about in the beginning of the video that we'll have to do to balance the basic solution. So you see how we have 6 protons here, or 6 hydrogen cations here. First thing you're going to do is to balance these 6 hydrogen cations here, you're going to put 6 hydroxyl anions on the reactant side to balance these 6 hydrogen cations. So let's go and write this a little bit smaller and squeeze it in here somehow, okay? So we're going to have our 6 iron 2 plus, and then this is going to be the different part, is that we're going to add, let's go write this in blue, our 6 hydroxyl anions, okay, on the reactant side to do what? To balance our 6 hydrogen cations, okay? Because whenever we see hydrogen cations, we know we're dealing with an acidic solution. Okay, so it's going to balance that, and so we write that to balance that, and then we make everything stay the same, because nothing changes here. So write the product side the same, okay? And okay, so here's what's going to happen now. Since we added, after you add these 6 hydroxyl anions on the reactant side to balance this out, you're going to have to do, remember, if you do one thing to the reactant side, you have to do that same thing to the product side, or else the product side is not going to be happy. Okay, so let's go and write that down. Let's go and write this down first, and we'll look at it. Okay, so everything stays the same. All right. I don't know what is up with the dots. I really don't. All right, so 3 plus anion plus the bromide anion. Or did I say 3 plus? No. 3 plus. It's obviously not an anion because it's not a negative charge. Sorry about that. I don't know what's happening today. All right, and 3 water molecules. And then this is where it's different. Remember, if we do one thing to the reactant side, we have to do the same thing to the product side. We added 6 hydroxyl groups to the reactant side. We have to add 6 hydroxyl groups to the product side. Okay, so we're going to add our 6 hydroxyl groups to the product side. Next, what happens is, remember, the formula for water is H2O. So here, what we're going to do is we're going to combine our 6 hydroxyl groups with our 6 hydrogen cations and make 6 water molecules. All right, so the last step is just going to be to write it out. So we're going to have 6 iron 2 plus cation. It's a cation, right? 2 positive charges, 2 cations, iron 2 plus, and then we're going to remember we're going to add these two together. We're going to add our 6 hydroxyl groups and 6 hydrogen cations to make 6 water molecules. Just go and write it straight up. Okay. So 6 water molecules plus our bromate anion, and then everything else stays the same until we get to our other side. Pretty much everything literally stays the same. Okay, so let's just try to see the end result here that we've been working on for 20 minutes. Sorry for making this video long, but hopefully it made sense to you guys. So our 3 plus cations there, and then we're going to add our bromide anion and our 3 water, and then our 6 hydroxyl groups. All right, and after we're done doing that, we're finally done balancing our redox reaction in a basic solution. All right, so you can see from an acidic solution, if you balance a redox reaction in a basic solution, it has a couple more steps at the end, okay, dealing with these hydroxyl groups and trying to convert these into water. Okay, so we're pretty much done now. If you want, you can go and check the coefficients again and the charges to make sure we're balanced completely. So we have 6 iron atoms here, 6 iron atoms here. All right, so iron's good. Let's do hydrogen next. So we have 12 hydrogen atoms here. We have 6 here on the water, and then we have 6 hydrogen atoms here for the hydroxyl group. So hydrogen's good. In terms of balancing, we have 6 oxygens here plus our 3 oxygens here. So 9 oxygens total on the reactant side. We have 3 oxygens here and 6 oxygens here. So 9 again on the product side. So oxygen's good and balanced. Last but not least, let's check our bromine atom. So we have 1 bromine atom here, 1 bromine atom here. So in terms of law of conservation of matter, we're good, right? Balancing number of atoms on both sides. Now let's see if the charges match. Okay, so we have a 2 plus charge here, but we have to multiply that by 6. So we have a total of 12 positive charges here, and we have a -1 charge here. So we have a net total charge of positive 11, right? Because 12 minus 1 is 11. So we're going to have a positive 11 charge here. Now let's go to the product side. We have a 3 plus charge here with 6. So we have to multiply 3 plus times 6, which is a positive 18 charge. Then our bromide anion, has a -1 charge. So 18 minus 1 is 17. And then we have 6 negative charges here. And 17 minus 6 is 11. All right, so we have a positive 11 charge here also. Okay, so our charges match, our number of atoms balanced on both sides match, and so in total, this is our balanced whole reaction in terms of a basic solution. All right, redox reaction balance in terms of a basic solution. So I really hope this video made sense to you guys. All right, in my future videos, I'll talk about more cool topics about biochem, and physics, and chem. And so I really hope to see you guys there. And don't forget to like and subscribe and hit that notification bell. And make sure to stay safe.